So this will be our initial fracture. And we can see that the name attribute here is set to override for our Boolean fracture node. So let's actually go back to our first Boolean fracture, and we have to keep tabs on this name attribute that we create. So first we will create our name attribute here for the first fracture, right where we separate this surface portion from the base. And let's maybe just rename this, or actually I'll keep this to piece, and we can see here that the name attribute is set to override. Okay, so now we should have two pieces, or rather two attributes for our primitives, that is piece 0 and piece 1. Okay, so let's go to our second fracture over here. So we want to keep our original name, so we want to know where these pieces originated from. So we will set this name attribute over here to append. We also just want to make sure that pretty much all the Boolean fracture operations that we do from here on, this name attribute setting here is set to append, because we want all of the sub pieces of our fractured pieces to have unique names. So for piece prefix here, I will just replace this piece value with just a simple hyphen. Okay, and if I go to the geometry spreadsheet, we can see that we have piece 1, which is our original, so where the piece originates from piece 1, and then we have a hyphen, and over here where it says 0, this will be our newly generated piece, right? So this goes all the way up to 1, 2, see 3, and we have an error over here. If I go to my scene view, let's drop down an exploded view, and the problem here is that we can see that there are these very small chunks here that created from the intersecting of the cutter planes. The easiest way to fix this is to just simply get rid of this, and from here I will actually drop down a measure node, and I want to measure the area, and I will say accumulate per piece, and the piece attribute will be name. Alright, so now our primitives all have an area value, and we can go all the way down here, and we can see that all of these very small values, we can simply delete this, we can simply delete those pieces. So if I were to drop down a blast node, or actually we can drop down a split, and let's add a custom threshold value here for our split node. I will go to this cogwheel over here, edit parameter interface, and I'll just drop down a simple float into our parameters. So grab this float and drag this over here, and let's rename this to threshold. Hit accept, and I will right click and copy parameter, and I will say over here for my group, if at area is higher than, and I will right click and paste relative references. Now as I increase this threshold, we can start to see our small parts disappearing, and we can preview what exactly we are calling if I were to drop down a null here from my second input of the split, and we can see here that these are the pieces that we are deleting. Alright, so if this threshold is set to 0, none of these chunks meet our condition. So as I increase this just slightly, we can start seeing the chunks being populated over here. So I'll just increase this value a bit. If I increase this value enough to maybe, let's say, a value of 746, we start to call out the big pieces as well. So we only want to call out the small pieces. And really what we should be left here from my first input is, if I drop down an assemble node, we should have only 5 pieces if we pack this. So if I drop down this assemble node and set this create packed primitives on, we see that we have 5 prims or 5 points. So now we have only the larger chunks that we want to work with. Okay, I will delete this assemble node because we won't be needing this yet. So the way we set up the next part of the fracturing is we are going to iterate over each of these slices individually. So from here, from my first input of the split, I will drop down a for each named primitive. And if I were to set this to single pass, we can see now that we isolate each of these slices individually. Alright, and let's only focus on one slice for now. And the first, we will have 3 layers of fracturing. And the first one will be a simple fracture by using a grid plane that we just sort of spam all over this entire surface. So from here, I will drop down a VDB from polygons, so we want to turn this into a density volume, and I will turn on fog VDB and disable surface. Okay, and here we can now scatter some points inside this volume. So drop down a scatter node, and I don't need the relax iterations, and also turn off maximum points, and I will just set the force total count to maybe 12. So we can create a grid outside of this network, and we need to make sure that when we copy this grid onto our surface, that this grid is big enough to intersect the whole geometry. So maybe I can also preview this node over here, so our 4-inch end, and we can guess how big this grid should be. So I'll just increase the size maybe to 50 and 50. Okay, so now no matter where we copy this grid and no matter what angle this will have, it should probably slice all the way through the geometry. So just make sure that this is big enough. If you find that you have some weird cuts on your geometry that isn't going all the way through the geometry, this is probably the cause that your grid size isn't high enough. Let's also increase the rows to maybe 250 and 250 for columns and rows, so we have a lot of geometry to work with. So I will drop this into a copy to points SOP and place the second input as our scatter. So if I preview this, we have all of our planes being scattered onto our points. We have to randomize the end, so we want all of these planes to have a different direction or angle. So let's drop down an attribute VOP after our scatter. And I will rename this to randomize angle. Inside here, let's grab the ptnum and generate a random. And I want to set the signature to 1D integer input 3D vector. So we want to generate a random vector and also fit this random vector from 0 to 1 to -1 and 1. So if I plug this into the n attribute for our points, now all of our planes should have a random direction. The problem here is that I want most of these planes, or rather all of these planes, to be standing sort of straight up. So I want them to be aligned on the y-axis. So for example, if I were to simply create a parameter here, and I will rename this to up, and let's set this to be a 3-float value, and I want this to be just a vector pointing in the y direction, so pointing straight up. I will set this to be 0, 1, and 0. And if I plug this into my n attribute, now all of these planes are sitting straight up. And now the problem is that they are sort of lined up in the same direction. So we want to randomize the direction they are facing. And we can use this random vector that we generated earlier to export this to the up vector attribute. So from here I can type bind export, and I will set this to be named up. We can see that they are standing straight up and they are facing, all of them are facing a random direction. Okay, so maybe if I go up and let's maybe template our planes and preview our geometry, we can see that this is kind of the intersection that we get. I also maybe want to add a little bit of randomness to this up vector direction, so I don't want them to be completely straight up, but I want them to have a sort of you know, maybe 20-degree inclination. Let's see what I mean by this. If I go back inside here, we have a random vector that's coming out of this fit function, and with this up vector that's plugged into the n, I can drop down a add node, and I can add to this up attribute this random attribute that we generated. Okay. And I want to have control over how much this random vector influences our up vector. So here I can drop down a multiply node. I will promote the second input and rename this to amp for amplitude. And also let's make sure that whatever vector is coming from this add node is normalized. So drop down a normalized node over here. Okay, and if I go up, we have our control for the amplitude. So now we can control exactly how much we want our n to be randomized. So I can just increase this value here. And so I just want to add a little bit of randomness, just so they are not aligned completely straight up.